Next, we move on to the next topic is control chart. The control chart, we have the various data are collected from the various process. From the process, the values, finding values are used to make a chart which is called as control chart. And no other tools are captured for the voice of your process better, and the control chart used to determine whether your process is operating in a statistical control or not. Where the control chart concept is, it is a graph which is used to study the how the process changes over a period of time. So the data are collected, and those data are plotted by the graphical term. So there will be three lines are indicated. There will be a center line, upper line, lower line. Where the upper line indicates, it is called upper control limit. Where lower line indicates the lower control limit. Okay, so the values, the plotted values may be increase or decrease. If it is increasing more than the upper control limit, not meeting the specification, or below the specification limit, also not meeting the required specifications. Most examples of the control charts are considered to be fluctuations, common causes, and special causes. Especially, the problems may be sometimes arises in the process, and based on the variations, the values may be increase or decrease. There are the different types of control charts are used. One is the X bar chart, or the standard deviation S control chart, or U or C control chart, or P or NP control chart, or pre control chart. So these are the types of control chart used in the process. Now the comparison between the control chart and for the variables and attributes. The control chart for variables and the control chart for attributes is we have found by the variations of whereas variables, these control charts are used for the measurable characteristics, where the attributes, these the charts are used for non-measurable characteristics and situations where the control charts are variable are not applied to due to the cost factor, time or cost factors, where X and R charts and S charts are used for the variables, whereas C, U charts are used for the attributes. A small sample serves the purpose of very well, where the large samples are required for the correct the conclusions, where the cost inspection of unit is large, whereas the cost inspection unit of the attributes is very small. So these charts provides for the better quality control, where these charts are not varying the better quality control. So these charts are not easily understood, where these attribute charts are easily understood. Control charts, we have the divided into two types. One is the variable charts, attribute charts, where X or S are variable charts, P charts and C charts are coming under attribute charts. So this is the graph shows for the normal curve. So there will be a center line, upper line, lower line, where the specification limits are varying between the upper control limit to lower control limit, where the center value. So between the values of lower to upper control limit, then it reaches the specification, or it is called as the statistical control. This is the graph shows for the C chart for the residential fault. Sometime all values from starting to end values, there will be huge variations between upper limit. Most of the values are coming to upper limit, or most of the values are coming to the lower limit. So that values are indicated here, and it not reaches the specification limit. This is the flow charts indicates the process improvement of the control charts, where there will be a input output in between the process, and whatever the outputs are getting, those values are measured, or some of the errors are obtained from the output, that will be measured and it will be corrected in the input. Where for example, if you, the 100 percentage of input is entering, the process or takes place, output will be getting around 90 percentage. Then the remaining 10 percentage will be recycled back or measured back, and that will be entered into the input. And when input entering 100 percentage will be reduced to 90 percentage, then added with the 10 percentage, and again the process will be continue. So in the earlier stages, the control charts are used for understanding the behavior of the portions, where after corrective actions place the charts to make the variations. This is the improvement control charts for sustaining when the input, process, output, measuring elements. So the same like the previous graph, previous flow charts. So this charts is mainly for sustaining, which means controlling the limits. Okay, where the over period of time, or eliminating the need of the SPC charts for having the preventive measures in the places. Now we're going to see about the another most important topic is defects and defective charts. What are defeats and defects? Customers' expectation is a product or service to meet their specification. When they don't, then defeats or defectives are present. Defeats is nothing but each characteristics or process output that does not meet the customer specification, which is also called as non-conforming conformity or defeat. Where improving quality means reducing the defeats to million opportunities, DPMO. Okay, so there are the attributes to this metric that can be controlled. So this is the definitions are given, and from the defeats we can divide into two regions. One is the opportunity, another one is defeats. Where opportunity is nothing but reducing the number of steps handoff or the other opportunities will help to improve the quality, whereas defeats, reducing the number of defeats for each process and steps through the continuous improvement will help to improve the quality. Whereas the defeats, the defectives, an item said to be non-conforming the items are defective if it falls on to conform the specifications in any of the characteristics. So the items or service that considered completely unacceptable for use. So that means total process will be recycled or rework will takes place for the defectives. Example, the final shipment or the quality inspections are found by the any automobile parts, and the rate of the items are checked, then the products may be pass or fail, which means may be supply or may not be supply. This is the comparison between the defeats and defectives. Defeats are all those the non-conformance of that are not acceptable by the end of the customers, then likely to imbalance the shape of the garments, or broken button or other trims or holes or fabrics, or the slip stitches or broken seams are examples of defects. That means totally we have to change the values. Whereas the defective piece is nothing but in center portion or in between the product, some small cases will happen. So that will be can alter for during checking, and which will be corrected in the intervals. So this is the bold shows that the defect and defectives. Defeats a single or non-conforming quality characteristics. The qualities are not good. Where defectives are items having one or more defects. Some small minor mistakes are identified